Start by turning on the oscilloscope. Once it has booted, we'll return to the default setup by clicking the default setup button. Then we'll set up probe number 1. We'll set the probe gain to 1. And we'll set the probe units to volts. Then we'll set the sensitivity of the probe. Set it to 500 milliamps per division. You can see it up here. Then we'll set the horizontal sweep time to 100 milliseconds. That is 100 milliseconds per division. And there's 10 divisions, so it's 1 second. Next, we'll offset the acquisition by 500 milliseconds, so that the acquisition starts at the beginning. Now the acquisition takes 1 second. Next, we'll add a measurement. You can see there's a lot of measurements. We need to find the average time. It's just up here. There, for the full circle. So now we have an average of the full circle along with the frequency and the peak-to-peak voltage. If you don't want all that, you can clear the measurements. Then we can add a new one by pressing the entry button. Now we can see what the average is of the entire sweep. Next, we need to set up our system. First, power on the motor. Then check that the sensor is connected to power. Then test your system by turning the motor, then braking, and seeing that there's an output on the oscilloscope. You'll be able to provide 3 to 500 millivolts. Next, go to your computer to the R+ manager and connect the system. Verify that the dongle is blinking red and green when it's connecting. There we are, we found one servo. Click Next. Now you need to set the operation mode to PWM control. Press Save. Go to the goal PWM. You can set the goal by changing the slider, but it won't do anything until you enable the torque. Now you can set the torque and drive in either direction. Start by setting it to 0. Have a look at the present velocity. This is important. You need to check that while you're working. You can then set a value of the PWM to, let's say, 500. And then we'll read the velocity and the torque that it's producing and put it into the schematic. In this case, the PWM is 500 and the velocity is 168. And the torque we can read off the oscilloscope, and I'm not pressing the brake, so it's 0. Then do a couple of PWM settings with different velocities. Try and see if you can hit that velocity by braking. I'll check the present velocity until it kind of hits the velocity that I want. Remember that you're doing averaging, so you need to keep a constant pressure for at least 1 second. Input the torque, in this case 440 millivolts. Also note that the torque is measured in ticks per second. Make some space for more measurements. In this case I just put in 100 and 885, which is the max, but I recommend that you put in even more. Now it's just a matter of filling in the table with all the values that you find necessary. I recommend that you try at least 4 different PWM values and that you set at least 4 different velocities for each PWM value. Once you have all the values, look in the exercise on how to convert those into the constants C1 and C2 that you need in your model. That's it. Enjoy your exercise.